So hi everyone, today we will try to understand what is Anova, that is analysis of variance method for accepting or rejecting a null hypothesis. So first of all, let's understand how it is different from hypothesis testing. So basically assume that in a hypothesis testing problem, we have been given data set for two seasons. One is winter, other is summer, and weight of a group of people accordingly. Now the problem statement, the hypothesis that we need to prove is can be whether the weight of people changes in the two seasons or not. So in such cases, as we have just two variables, we can use hypothesis testing. But assume that we have conditions like this: whether season winter, summer, and rainy. The third condition, the third category also coming in, or whether season and financial state of a person influences the weight gain. So if you see in these two conditions, we have two very different problems coming in. In the first case, whether season, we have now three categories coming in rather than two, summer and winter. So hypothesis testing can be used when we have two categories, but when we have multiple categories, we need to switch to Anova. Similarly, to accept and reject a null hypothesis. Similarly, in the second condition, you can see that the question is whether season and financial status influences a person's weight gain. So here also you can see that we have two independent variables now and not just one. So earlier we used to have just season, now we have financial status also coming, which is independent. So when we have multiple independent variables coming in, then also you can't use hypothesis testing. We need to use ANOVA method. So let's understand how this can be solved. The first condition where we have one independent variable but multiple internal subcategories is called as one-way ANOVA. Similarly, where we have multiple independent categories coming in, it is called as a two-way ANOVA. So in this particular session, I would be talking about how one-way ANOVA can be solved and a brief on two-way ANOVA. So the points to be noted are it is very similar to hypothesis testing, but the crux of the problem remains the same, that we are trying to using F statistic in place of Z statistic. We are trying to decide whether to reject or accept a null hypothesis, where we would be setting up a null or alternate hypothesis first, setting a significance level, and then eventually calculating F stat. And using that F stat, we will decide whether to reject or accept a null hypothesis. So let's see what to do. Assume that this is the data set that we have been given. We have been given the weight of three people. It is a very dummy data set. Just a very small data set so that we can see the calculations on our own. And we have three seasons given: winter, summer, and rainy. So there are three subcategories given a one independent category. Hence, it is a one-way ANOVA problem. So the null hypothesis is that mean weight for different seasons is same, and alternate hypothesis is that mean weight for different season isn't same. So this is the hypothesis that we have set up. Significance level is taken as 0.1. It can be 0.05 usually, but as of now we have taken 0.1. Step 1 is done. Now the next thing that we need to calculate is the mean of the three categories that we have been given. So the mean for winter is 20, for summer it is 14, rainy it is 60. You can go and check out with the sync up with the table that has been given. And the mean for the entire data set is 40. Now the next thing that we wish to calculate is total sum of squares, that is TSS. So how TSS is calculated? So TSS is nothing but the sum of squares of the difference between the different values in the different in the categories, subtracting the mean of that particular category. So here you can see that the mean for winter is 20, and the values for winter are 30, 20, and 10. So here what we are doing is that we're subtracting the mean of winter from all the winter values that we have got, that is 30 minus 20, 20 minus 20, 10 minus 20, and taking a whole square. Similarly, for summer also we are taking a possible values and subtracting the mean, taking a whole square. And similarly for rainy. So thus total sum of squares within, that is SSW, becomes 600. Now we will be calculating total sum of squares between, that is SSB. So SSB is nothing but the mean of the different subcategories minus the mean of the whole data set, whole square, into 3. So into 3 means that there is a total number of values present in that particular subcategory. So 20 is the mean of for winter, minus 40 the overall mean for the data set, whole square, into 3. 3 represents the total number of data samples present. Similarly for summer, similarly for rainy, we have calculated, giving us SSB equals to 2400. Now we will be calculating a degree of freedom for SSW and SSB. SSW was sum of squares within, and SSB is sum of squares between. So the degree of freedom for SSB would be m minus 1 equal to 3 minus 1 equal to 2. So where m is equal to number of subcategories. So it does make sense, right? Sum of squares for SSB, we are using three different variables: 20, 40, and 60. Now using two variables, the third can be calculated. This is what we call as degree of freedom. And for degree of freedom for SSW would be m into n minus 1. 3 into 3 minus 1 equals to 6. This is because in each subcategory we have got three values. So using two values you can get to the third one. So 3 minus 1 equals to 2. And as we got three categories, this will be equal to 6. So degree of freedom for SSW is 6. Now calculating the F stat. So F stat is nothing but SSB upon degree of freedom of SSB divided by SSW upon degree of freedom of SSW, giving us a 12. So F stat equals to 12. Now now similar to Z's distribution table, if you have seen in hypothesis testing, we have a F distribution table as well. So if you remember, we have set up a significance level of 0.1 initially. So if you look into this table, you will get the value for for the F stat, for the expected F stat. Now if the F stat calculated by us is greater than the expected F stat given in this particular table, we can reject the null hypothesis. Now this was all about one-way ANOVA. Talking briefly about two-way ANOVA also. So in this case, where we have two or more than two independent variables, would be having multiple null hypotheses coming in. So see this. So when we have season and financial state, we wish to check whether season and financial status of a person affects the weight. So we would be having three conditions coming in. So whether season influences weight, whether financial status influences weight, these two can be solved using hypothesis testing. The third one being whether season and financial state influence each other. So the null and alternate hypothesis will be set up for all these three problems, and eventually they would be solved to get to a solution for two-way ANOVA.